record. Ada record warna merah tapi.
Okay.
Dah sudah cakap
Okay, tu mic semua. Betul mic. Mic dah suara. Okay dah.
Okay, Assalamualaikum warahmatullahi wabarakatuh. To my dear lecturer and my fellow friends. Okay, today we gonna present about assignment 3. The title is band pass filter. Okay, let me introduce my group mate. Okay, start with Muhammad. Start with TAIB. Umar.
Assalamualaikum warahmatullahi wabarakatuh. My name is TAIB URZAIZ bin TAIB ZIAD. My card matric number is B08 211 0569. And Eddie?
Assalamualaikum. My name is RUSYAIDI HAZIM bin SOFIAN and my matric number B08 211 0334. Okay, next.
Okay, Assalamualaikum. My name is MUHAMAD Daniel bin ANANG SYAFRIZAL ANWAR. My matric number is B0821110133.
Right. It's my turn. My name is MUQRISH bin AHMAD AZIZI. My matric number is B0821110158. Right. Okay, let me start with introduction. Okay. For band pass filter can be used to isolate or filter our certain frequencies that lie within a particular band or range of frequencies. Right. Let my friend share the screen first. Sorry. Okay. Okay, let me start again. Okay, I will start with the introduction. Okay. Band pass filter can be used to isolate or filter our certain frequencies that lie within a particular band or range of frequencies. The cut-off frequencies or FC point in the example RC passive filter can be accurately controlled using just a single resistor in series with a non-polarized capacitor, and depending upon which way around they are connected, we have see that either a low pass or a high pass filter is obtained. One simple use for this type of passive filter is in audio amplifier application or circuits such as in loudspeaker, crossover filter, or preamplifier tone control. Sometimes it is necessary to only pass a certain range of frequency that do not begin at 0 Hz, okay, in bracket DC, and at some upper high frequency point but are within a certain range or band of frequencies, either narrow or wide. By connecting or cascading together a single low pass filter circuit with a high pass filter circuit, we can produce another type of passive RC filter that passes a selected range or band of frequencies that can be either narrow or wide while attenuating all those outside of this range. This new type of passive filter arrangement produces a frequency selective filter known commonly as a band pass filter or BPF for short. Alright. Okay, let's start with TAIB UMAR, right? For the second.
Yeah.
Okay.
Okay, for my part is Main aku tak dengar.
Dengar.
Okay, for my part is the procedure. Each value of every passive component must be assigned a value. 3 components can be found in this bandpass filter circuit, which are resistor, capacitor and inductor. The value fixed for the component are 1k ohm of resistor, 0.47 microfarad for capacitor and 1 millihenry for inductor. The transfer function of the circuit is derived by applying voltage divider. Vout is obtained, J omega is substituted as S, and the equation is simplified to its imaginary part, and the equation is simplified to its imaginary and real part. The magnitude of the frequency is calculated. The phase frequency response is also obtained by selecting the imaginary part in the derivation. Arbitrary circuit is sketched and source are set to 0. The intent is to reduce the ratio of the output voltage to the input current of a mesh in a network. With this, the type of transfer function is formed. The bandwidth pass filter is given by bandwidth frequency high minus frequency low, where frequency high and frequency low are the higher and the lower cut-off frequency. The value of frequency high and frequency low are given by frequency high is equal to 11 kHz and 1 kHz. The circuit is built in multisim 14.2 software. The component used in the circuit are same value as monitored in step 1. The amplitude of the function generator is set 6 Vp and frequency is set at 1 kHz. The circuit is simulated and the output of the voltage is measured by using oscilloscope. Step 5 is repeated by changing the frequency from 3 kHz to 11 kHz. The data is recorded, is analyzed. The result of the observation discussed along with the capability of the circuit. Simulation results are attached below to allow the checking of the circuit construction and also the simulated result. So this is our calculation to find the transfer function. There are 2 parts. Okay, the next one I will give it to Daniel.
Okay. First, we use inductor. Then we choose capacitor. So, choose a capacitor. Any value. And then resistor. Flip the resistor. Find the function generator. So the positive functionator to the terminal, the inductor, and complete the circuit. Find the oscilloscope. The input terminal A to the input inductor. B terminals go to the output. Find the grounds, all groups, ground. Negative to the ground. Set the inductor to the 1 milli. Capacitor 0.47 farads. Resistor to 1 kilo. Bro. Tak ada. Oh, yes, yes. The ground to the ground. So functionators set to the 1 kilohertz. Amplitude 6 VP. Oh, so that's a complete circuit that we find the node. So that is the result. Section A to the oh, that's all for me.
Okay, for my part, bye. Okay, for the discussion, the bandpass circuit is made up of a single voltage source, capacitor, and inductor and resistor. The amplitude is fixed at 6 volt, 6 VP. The output voltage is measured at resistor. The output voltage is measured for varied frequencies from 1 kHz to 11 kHz. After analyzing the result, it can be said as the frequency increase from 1 kHz to 7 kHz. The output value increase, it can be said there is voltage gain at its maximum. From 7 kHz to 11 kHz, there is voltage drop. This happens because the bandpass filter allows frequency in a particular range to pass through the dismissed frequencies outside of range. So the bandpass filter accept the component throughout the bandpass of component but reject frequency above and also below this band. The bandpass circuit utilized in circuit while the bandpass circuit utilized in wireless transmit and receiver. The objective of this filter is to restrict the output signal of bandwidth assigned specifically for the transmission. The bandpass filter will prevent the interference of other stations, while in receiver, the bandpass only allow signal in particular range of selected frequencies. So for the conclusion, an ideal bandpass filter would have a completely flat bandpass. All frequency with the bandpass would be passed to the output without amplification or attenuation, and would completely all frequency outside the bandpass. In practical, no bandpass filter in ideal, the filter does not attenuate all frequencies outside the desired frequency range out completely. In particular, there is a region outside the intent bandpass where frequency are energized but not rejected. This is known as the filter roll-off, and it is usual aspect in dB of entire per octave or decade of frequency. So that's all from me.
So thank you for to my friend for this presentation, and thank you to madam. That's all from us.
Thank you.
Okay, and thank you.
Thank you.
Thank you.